Okay, so today we are going to be doing lesson, I already forgot what lesson number it is, because I got the nerd. Okay, yeah, lesson 28, here we go. And who read my objective for me? Jeremiah.
We can add a mixed number and a fraction.
Yeah, and today we're going to be adding a mixed number and a fraction. Now, what makes up a mixed number? Drea.
An improper fraction is you breaking it apart into a number of wholes in a fraction.
Awesome. The first part about the improper fraction is just you being very smart, but really, and how to get to a mixed number, but a mixed number is a whole and a fraction, okay? So today we're going to be taking that whole and that fraction and adding another fraction. That's basically all we're doing. And we talked about before we were interrupted by our phone call in our last video, we said, what do we need to add fractions? And we said that you need common denominators. Because as soon as you have the same denominator, you can add your numerators right across, okay? So today, unlike yesterday, they're going to be giving you pretty much every fraction with common denominators already. So that works out to your guys' advantage. So the first one I want to take a look at today is 2 3/8 plus 3/8. Now, what do we need common denominators? Do we have a common denominator?
Yes.
Yeah, remember when we started this adding fractions originally, I said you have to do your denominator check first, just to always kind of get your brain ready. So, if you do your denominator check, obviously here we have 8 and 8, so we can add our numerators now. And if we add our numerators,
It's 6.
it is 6/8. So you have to make sure that you also bring over the 2. So 2 3/8 plus 3/8 is 6/8. Okay? Now, the next example I want to give you guys is a little bit different. You're again going to have a denominator that you're familiar with, and that's 2 and you're going to use the same fraction, 2 3/8. Except this time I'm adding 5/8. I want you to turn and talk with the person next to you. What makes this problem a little bit different? Turn 3, turn 2, turn 1. What makes this problem a little bit different? Go ahead.
This
Dre, I'll come to you.
problem makes it
the same denominator, but then they don't have the same
denominators, but they don't have the same numerators.
But it just has
Basically,
different.
and if you was to add those, it would become
Turn 3,
1 plus 2
turn 2, turn 1. So what makes this new problem of 2 3/8 plus 5/8 different from the original problem we just solved? So one thing that Andrea had said was that she told me, and being a good partner, that we have different numerators. So that's a change from this problem for sure. But now let's go a little bit beyond that. Why do you think this problem is a little bit different than the one we just solved? Kamora.
I think it's different because if you were to add 5 and 3, it would equal a whole.
That's exactly what I was looking for. Because if we add, hang on one second. Because if we add 2 3/8 and 5/8, or I should say the 3/8 and the 5/8,
make 8.
how many eighths is that, Miguel?
8.
That's 8/8.
So what's in
So now we'd have 2 and 8/8. But what do we know about 8/8, Jeremiah?
that it's a one whole, so if you add it, it's gonna be 3.
Yeah. So this is really one whole. So this really 2 8/8 equals 3. 3 wholes. Okay. We'll do one more, and then we're gonna do a second one that's a little bit different. But I think you guys will catch on to that pretty quick. Okay. So we're gonna do it a little bit differently this time. I'm gonna say this time, I'm gonna give you guys 3 1/8 plus blank equals 4. 3 1/8 plus blank equals 4. So you need to be looking at what you already have and how you're gonna get to your total. Justin. 7/8. Justin, why do you say 7/8?
Because I mean, this one is 8, and then you have 3, and you add them all is 4.
Absolutely, because what Justin said is absolutely right. Justin was thinking, he knows that 4 is a whole, and he's thinking to himself, how do I make a whole from 1/8? And he said, I already have 1. I need 7 more to make a whole. So 3 and 1/8 plus 7/8 equals 4, and that's 100% correct. Jeremiah.
What if like now?
Okay. If it comes back to you, let me know.
Yeah.
Now, the next thing I'm going to show you is where it gets a little tricky. But we talked about this a little bit already when Andrea was telling me what a mixed number was in the first place, okay? So I'm going to give you guys 5 and 2/4 plus 3/4. Now, if I do a denominator check, are my denominators the same?
Yes.
My denominators are the same. I've got 4 here and I have 4 here, so that's great. Now I'm ready to add. Now as I'm looking to add here, what makes this problem, or this equation I should say, what makes this equation different? Angelo.
It makes a difference because when you add it, it's 5/4, so you might be
Okay, so I'm going to stop you right there. It is absolutely 5/4, but what is 5/4? Talk to me about 5/4. Why is this now different? Why might this be a problem? Morella.
Because it's 1 whole and 1/4.
Ah, because Morella jumped out and said this is 1 whole and 1/4 because this is an improper fraction, right? So when we get that improper fraction, instead of leaving it as 5 and 5/4, we have to do the improper fraction treatment. We have to separate out the whole, so 4/4. And then Morella was so smart and she said that there's 1/4 left over. So now I had 5 holes. I found another one. So now how many holes do I have?
6.
I have 6 holes. And what, Morella?
1/4.
1/4. Good girl. Jeremiah, have a seat, please. And 1/4. Okay? Now, that's one way of solving this. The other way of solving this, and this, you're going to see both ways. I kind of prefer this one, but I see where the other one comes from too, and you guys might like that better, so I'm going to show it to you. So now imagine it's the same problem. I'm going to have 5 and 2/4 plus 3/4, right? I'm looking at these two fractions because I'm adding the two fractions. And right away before, you guys knew that these two fractions were going to be more than a whole. Now, what you can do is you can take the fraction that's with the whole and say to yourself, well, I have 2/4. How many more fourths do I need to get to the next whole? Not 1/4.
2/4.
I need 2/4. What I can do is I can separate, before I even add, Miguel, I can separate 3/4 into 2/4 and 1/4 with a number bond. And when I do that, I can see that my 2 and 2/4 and the 2/4 here make what?
A whole.
Listen carefully. 5 and 2/4 and 2 more fourths is 6. And then what's left over? 1/4. So instead of sticking yourself with an improper fraction, make the whole before and then just add on what's left over.
Is it like cutting something? Like
Yeah, it's breaking this fraction apart to make the whole without having to worry about the improper fraction part of it, okay? So that's 2 ways you can go with this. Now, I am going to have you guys go back You're gonna take problem set 28 on your own for about 10 minutes. I'm gonna check in with you guys then, and we'll go from there. So, one, get ready. 2, stand up. 3, and go.